We've all been there, in the middle of a job, everything going smoothly, until boom, you're missing a part. United Refrigeration is your one-stop shop for all your refrigeration needs. Use your computer or smartphone to go to www.uri.com at any time of day or night to check stock on your favorite brands, such as Copeland, Sporlan, Carlisle compressors, Danfoss, Emerson CPC boards and sensors, Carrel, Hussmann parts, and K2Therm. United Refrigeration, Inc. is home to these brands and many more. Looking for information on refrigerant conversions or refrigerant banking? Quick access links on the homepage can get you to the information you need. All approved accounts are able to see live to-the-minute inventory and pricing. Product not in stock at your local branch? No problem. Use the Nearby Stock feature to find a local branch that does have what you need. Are you looking for a branch address, phone number, or after-hours number? That's all available as well. Just click on the branch locator and search for your local branch. Have a model number and looking for a replacement part? www.uri.com/ARP has a vast list of quick pick replacement parts. Just search for the model number of the equipment you're working on and click the Replacement Parts tab. If you don't have an account, click the Register button and we'll have you online in no time. With more than 400 locations in North America, each United Refrigeration branch is fully stocked for immediate pickup. Our branch employees have in-depth technical knowledge, so we can help you get what you need when you need it. Visit your local store or www.uri.com/ARP today. United Refrigeration, Inc. has all your solutions down cold.
The Sporlan division of Parker Hannifin Corporation is sponsoring this podcast. Sporlan is the leading manufacturer of HVAC and R components. Using quality materials and craftsmanship, Sporlan maintains a commitment to innovation, manufacturing excellence, service, and support for its customers since 1934. The company is known for its catch-all filter dryers, thermostatic expansion valves, solenoid valves, pressure regulating valves, suction filters, electric valves, controllers, supermarket monitoring solutions, chemicals, smart service tools, ZoomLock Max Press to Connect, and ZoomLock Push to Connect refrigerant fittings. If the folks want to learn more, what do? You could go to sporlan.com. I guess that's Jim and John for Sporlan signing on.
Good evening, everybody. Welcome to Advanced Refrigeration Podcast. You're in your host, Brett Wetzel and Kevin Compass. And we have a special guest from Guntner, William Anaya. Anaya. Damn.
It's okay.
Oh, my
Everyone
goodness. I told you I'm horrible. I'm the world's best phonetic speller. That's my problem.
Okay.
Yeah, so tonight, Will's coming on here to talk about Guntner products. Not just you can get this here, We're going to talk about actual troubleshooting and some programming stuff. And so you're a lot more confident when you're working on these things. Will, you want to start and tell everyone a little bit of background about yourself? How long you've been at Guntner? What do you do specifically for Guntner? And just give us the quick and skinny, man.
Sure, no problem. My name is William and I've been with Guntner for a little over 3 years now. It's gone by fast. I am the electrical and controls engineer here. All controls, all electrical stuff. I'm your guy here at Guntner. Before Guntner, I worked at Johnson Controls and I was in controls there. So yeah, just that's what I do. I'm all controls and electrical. So if you guys ever need any assistance with any of our Guntner products, let me know. I can definitely help you guys out. If I don't know the answer, I can definitely find someone who does. So
sorry. Yeah, I know. I just saw that. So, like I said, tonight we're going to talk about Guntner. I guess we're going to keep it and start talk about the Abatic gas coolers, right? Unless you want to talk a little bit about the. I don't know if you have any information about the dry coolers on there, because I know on some of the cooler climates, like up in Kevin's area, sometimes they do have the dry coolers, and I am aware that you guys also make dry coolers because you sent me all your control data information on that. But
Yeah,
yeah, let's get into it.
we have dry coolers. We have the adiabatic units. We have, I think the adiabatic units is what you guys are most familiar with, what you guys have used the most. And the way those operate is you have a process fluid. You're just trying to maintain that process fluid set point, whether it's glycol or water or CO2, whatever it is. And there's the fans that ramp up and ramp down to maintain the set point. And then when they can no longer meet the set point, we have the adiabatic side, which is water that goes across the pads to help maintain that set point. And what we do is we have our own controls company. So we actually manufacture our own controls, and we have our own control logic. And I can actually go into a little bit about that and how our controls actually work if you like.
Yeah, for sure. Do you want me to share this up?
Yep, sure. That sounds good.
Go.
So just here, let me go over here. All right. So basically what our GMM does, it maintains the set point of the fans. So we control the fan speed using our Guntner controller. There's a lot of different features that we have already built into the controller. You can have our units standalone mode. You can have them in server mode. You can have them maintain their own thing. So let me go to this next slide here.
Okay.
So this one kind of shows it a little bit better. So we have a standalone, analog, and field bus. So the unit can be in standalone mode where you install a temperature sensor or a pressure sensor on the outlet header. You put a set point directly on the controller and it maintains that set point. You can also, what's very common is have our unit in server mode, which is basically where you give us when I say you, I mean some other system, gives Guntner a set point via 0 to 10 or 4 to 20, a fan speed.
Mhm.
So, and I think this is, Kevin was discussing this before, and from the factory, our units usually come in standalone mode. So when they get to the field, a lot of the guys like Kevin are going through our controller and are struggling to set it up because they're not the experts in our controller and we understand it. So they could fumble through it and it's not working and it could get very frustrating. So I actually listened to your last podcast and I brought this up internally and we started a project to actually make sure that our controllers leave the factory set up per customer requirements so that the guys in the field are struggling a little bit less. I've been in the field. I know how it is. I get it. I wouldn't want to struggle either, especially when it's a controller that I don't know. But getting back to the control strategy. So you can send our controller a set point via 0 to 10, 10 to 0, 2 to 10, 4 to 20, Modbus, BACnet, however you want to do it. And it'll ramp the fans up and down. You can also integrate to the unit via a BMS system. So if you wanted to send the fan speed via Modbus or BACnet, that's also possible. We have, and also in manual mode too, but there's also a lot of different settings on here. So on the controller, you can do a secondary set point. So this is usually used on a unit that's standalone. So a lot of sites do have standalone. They don't have a BMS system. A lot of grocery stores have it standalone, but they might need two set points, one for winter and one for summer. So if you have it set up properly with the proper sensors, you can put two set points in the controller and based on the ambient temperature, our controller will know when to switch and have one set point when it's over 60 degrees Fahrenheit and another set point when it's under 60 degrees. And that's all done by itself. So
Can it do TD control? Like, can it do floating head pressure TD control in standalone mode?
yep, that's right here. So we have that also. So if you can do that. You can do that in standalone mode as long as you have the ambient temperature installed. It can do that because our controller needs to know what the ambient temperature is. So You can offset the temperature by 7 degrees Fahrenheit, and you can set a minimum and a maximum. So let's just say I want to offset my set point by, just to keep the number simple, 5 degrees Fahrenheit, and I want my minimum set point to be 60 and my maximum set point to be 85. So when it's 60 degrees out, it's going to offset by 5. So you'll be floating 5 degrees above that all the time up until you get to the maximum. And that's the most it'll go to.
So does that also mean then you guys have the capability, because you just said it can do TV control? Are you doing a TV control just based off the ambient, or are you guys actually breaking it down and getting the wet bulb temperature?
Well, the sensor is placed behind the pad on the adiabatic side. So it's looking at the temperature after it's already been cooled. So does that answer your question? It's not looking at the actual humidity to offset, but it is
Mhm.
placed after the pads.
Oh, okay. All right. No, I got you. Gotcha.
So, and then something that's, go ahead. I'm sorry. I thought you said
Nope.
something.
Nope.
Um,
Go ahead.
so we also have the ability to control a bypass valve natively in the controller. So if you wanted to wire a bypass valve into the GMM, it has that capability. So that's right out of the box.
When you speak of a bypass valve, what kind of valve are you speaking of?
Like a three-way bypass valve. So if you wanted to so like in certain situations, you might want to bypass our unit depending on ambient temperature.
The only time I've ever seen that is if you're dealing with like a cascade and you're basically just using part of the abatic as like a gap, basically just a desuperheater. That's the only time I've ever seen that separate.
Yeah, I'll be honest. I haven't seen it used too much, but there are a lot of our customers. I take that back because there are a lot of our customers that do use it.
Yeah.
But
For a lot of the dry cooler stuff.
it could be used on a dry cooler as long as the temperature pressure sensor is installed. Yeah.
Okay.
So it's just to bypass the unit if need be. So and then
And
here's I'm sorry.
that program resides in your controller then, right?
Correct. Yeah, it's already
Okay.
native in there. So it just needs to be wired up and the features need to be turned on in the controller with the settings.
Okay.
So another feature that we have, these are standard features on our controller, is the bypass mode, maintenance run, and ice break mode. So the bypass mode is, so what we do is we run individual Modbus lines from each fan directly to the controller. Okay. And what that does, that allows us to, if one of the fans, if one of the fans fail, I'm sorry, one of the lines of communication gets severed to the fan, then the fan will go into bypass and spin at 100%. It'll also let us know which fan is doing that. If a critical sensor or the controller fails, all fans will ramp up to 100%. So this right here is the number one service call I get. I'll get a guy in the field calling me, say, "Hey, listen, the fan is working, but it's not responding. It's only spinning at 100%." To which I'll say, "You know what? Check the wiring. Is there something wrong with the wiring? Is there a loose wire?" And sometimes a loose wire will bring it back, and it'll start spinning again. The other thing that's nice about this is what some of our competitors do is, instead of running individual Modbus lines, they'll run one Modbus line and daisy chain it from fan to fan. And the reason they do that is because it's cheaper. It's cheaper to run one line and daisy chain it. And then you got to program the controller and address each fan individually. With us, you don't have to do that. It's a little bit more work on the manufacturing side, but on the user end, it's easier because if a fan fails, you just swap it out and it comes alive. No addressing necessary. We also have a maintenance run feature, which what some sites do is, especially in the winter, and up here in Chicago, it's cold. This January, it's not that cold, but it normally gets really cold. And they will shut down the unit, you know, come January and not start it up until March. And our fans are designed to run. Because what could happen is if you shut a unit down and you don't let it run, the bearings on the fans can flatten, condensation can form inside the electrical terminal box and can cause damage to the fans. So what we do is we turn this feature on, and that tells the controller tells the fans to spin for 60 seconds during a 24-hour period. And that's programmable. You can make it run a little bit longer. But basically what that does, it prevents the bearings from flattening, allows the bearing grease to get in there and lubricate the fan. And if there is any moisture that penetrates the electrical terminal box, it can evaporate that away. And then another standard feature that we have is our ice break feature. What the ice break feature is if, and I actually had a customer call me up in, I think Quebec. They had a really nasty winter last year. And he was telling me that the fans were oscillating back and forth and then they broke free and he didn't know what it was. And it was because the ice was on there. Ice had formed on the fan and the fan started spinning back and forth and then breaks free and then starts spinning. If for whatever reason it can't break free, you'll get an operational message right on the controller telling you that it's not working.
No way.
Yeah.
So the another question I had, so like some of these fans, I'm looking at the layout, right? And I know this isn't exactly how all the fans go, but like Kevin, because he deals with a lot of lower ambient, being up in Chicago and Indiana and all those other cold ass places he's at, a lot of times you'll start logging a little bit of gas in there, especially if a whole split function wasn't set up to be done. Is there any way in your controller to either disable half of the fans, or are there ROs on that controller that control each
Yeah, so
individual fan?
yeah, it's a good question. So what a lot of customers are doing is, for instance, let's say that it's a 6 fan unit, right? With 2 coils, one on each side, and they wanna split the unit. On our controller, you can do it. So what I would suggest in that case is to send 2 0 to 10 volt signals, one for each side. And you can put it on the controller where, you know what, 0 to 10 for the left side coil, 0 to 10 for the right side coil. When on the right side, when you don't need any cooling on that, you just give it a 0% fan speed and it just doesn't run the right side and the left side is running however you need it to. Or
You put write up on that because like on how to like exactly do that setup like for the AI and the actual splitting up of the condensers because right there like that's killer right there because that just about in every single job that's been a problem I've seen.
Mhm. Yeah, what I can do is I can send you a configuration and you could upload it to the controller.
But
That's
so the one thing the question about the configuration when you do that, so say I go to a Target and it's got 4 double fans and I go to a Costco and I have 12 double fans and I load it in there. Now is it gonna mess up the Modbus setup for the fans or
something else.
and
So
go
what it does, that's a great question. So what it does is it looks, so let's say you have a unit set up perfectly. Let's say you go to Target and there's 3 units there. You set up the first one perfectly, right? And let's just say it's a 12 fan unit, 6 and 6. You set that up perfectly. You can pull that configuration from that controller, load it onto the next unit, and let's say the next unit is an 8 fan unit. It's 4 and 4, 4 on each side. When you load it up, the controller is going to ask you, it's going to say, okay, how many fans are on this unit? You're going to say 8 fans and 2 rows. And that's all you really need to do. You need to put that in there and then some fan identifier information that's located on the electrical diagrams. And it'll operate the exact same way as the 12 fan unit, but in 8 fans. And you can take that same configuration and take it to a Costco site and load it on a 6 fan unit there. So the only thing with that right now is software revisions. So one thing I didn't talk about is one of the ways that we're able to do this is because our controller isn't a microprocessor. It's a full Linux computer. And because it's a Linux computer, it makes updating easier. One of the drawbacks to updating and new software versions is if you have a configuration that you've been working with, and now you go and it's been set up on a 1.9 software version, just for just to put that out there. And you go to the new site and it's a 1.10. That what winds up happening is it's not going to read that software version. But one of the things I've requested, because we manufacture our own controls, we have a lot of control over everything. And one of the requests I made with our team in Germany was to make sure that the software revisions were backwards compatible, because I know how the guys in the field work. If they got one working, they want to pull that configuration and keep loading it. So one of the things that we're working on right now is to make the softwares backwards compatible. So if you do have an earlier revision of the software, and you pull that configuration, it'll work on a later revision. So I've gotten the promise that they're working on that right now. So as of recording this right now, it's still not available. So if you have a unit that you come across that's like a later software than the one you pull the configuration from, it won't work. But we're working on changing that. And that's one of the things, honestly, that I really like about here at Guntner, is that because we do manufacture our own controls, we have a lot of control over it, and we get a lot of input from guys in the field. Like, for instance, when I heard you guys in the last podcast say that it was that they don't come set up from the factory, and I agree with you. It was tough, but because of that, we're able to make those changes. So another thing is LCMM. So this is a feature. These are more of our advanced features. And on here, you have to turn this feature on in the controller, but it's a nice feature, especially for northern climates, because all of our fans ramp up and ramp down synchronously. So if you're operating a target with a 10-0 fan speed and you give it 30% fan speed, all the fans are going to ramp up at 30%. But if it's a day where it's super cold out, you can potentially overshoot your set point. If you turn this feature on, LCMM, what that does is, let's say you give it 10%, it's going to use one fan instead of all six. And then it's going to ramp just that one fan up until your load increases. Then it'll kick on a second fan. And as your load increases, it'll start using more and more fans. Another thing that we do is we look at the fans motor runtime, and when LCMM is turned on, we request the fan with the lowest runtime first, and then we go to the next lowest runtime, and so on and so forth, to extend the life of the motors. So that's a nice feature, especially for northern climates.
Are you guys doing that also on the you guys make microchannel?
I believe, yeah, I think microchannel is part of us. I'm not too familiar with that side of the business, to be honest with you.
I was just curious because I know anytime you have a lot of expansion and contraction on those microchannel, they don't like it.
Mhm.
The coils end up leaking. I know Kevin's had a bunch on those A-frame style coils, condenser coils that they have out there.
We've had a lot of leaks on gas coolers in general, just from I think it's due to fan control, but like what you just showed up here is like a big proponent of like stopping that, especially with your guys' stuff, is that having that set up, because like the way that they're all controlling them off drop leg temp for CO2 is just it's been nonstop problems. And until like we convince them all to not use drop leg temp any longer and use pressure, I mean, that at least dropping down to one fan in the wintertime would save a lot of that expansion and contraction, I would think.
Mhm. Yeah, no, this is a standard feature on our end. So, I mean, it's an advanced feature, but it's on every GMM with EC fans, and it's just a matter of turning it on and getting it running. So that's something that's nice.
I'm sorry.
No, go ahead.
No, I had another question. So are you guys doing the standard 0 volts is 100% and vice versa? Or are you going like for like 0%, 10 is 100%?
However you want to do it. Our controller can do 0 to 10 or 10 to 0, where 0 is off, or 0 can be 100%. It just really depends on how you want it to run. our previous controller, the GMM EC, that's our legacy controller. That one, you needed a inverter if you wanted 10 to 0.
An arm,
With
like
our
an
newest
arm, like an
controller,
arm board.
yeah. With our newest controller, it's built in, baked in. So
So
it's just a setting on the controller. That's another call I get sometimes where it's been set up, but it's not, the signal's not inverted. That's an easy fix. It's just going into the settings and inverting the signal.
So if you guys aren't familiar with what we're talking about, I know we've talked about this subject on many a podcast, but typically nowadays we like doing 0 volts as 100%. And the reason why is because if God forbid you would lose your analog output coming from your controller, at least if the thing shuts down, in the failsafe, at least all your fans are on. Back when they first started doing a lot of analog output control, they did not have it set up as that. So God forbid if you lost your analog output, you were looking for some kind of Hail Mary to get those fans running, just to get them just to get the rack back up and running. So what we're talking about is making sure it is inverted. So God forbid we do lose the analog output, we still have some fans rotating.
Yep. So yeah, you can do that. You can also do a custom signal if you want. I mean, if you want to do 2 to 10 or 5 to 10 or 4 to 20 milliamps or 0 to 20 milliamps. It's our newest controller. Like I said, because it's a full blown Linux computer, it's very versatile. So that's something that's nice. Another advanced feature is our natural convection control. And what this does is, especially, I think this is more used for CO2 applications, or the potential for it, I should say, because I'm not a refrigeration guy. I'm an electronic controls guy. But what I picked up a little bit is that on the CO2 side, if you lose heat, it could be bad for the system. And what we've done is, in our controls, we can tell if the fans are spinning due to natural convection. Because in the winter, when it's really cold, if there's heat in the heat exchanger, that heat goes up and can force the fans to spin. Well, what we'll do is, if our controller senses that, it'll actually spin the fans backwards at a very low speed, trying to lock that heat inside the unit, so you're not losing heat due to natural convection.
That
So
is
go ahead, Kevin. I'm sorry.
so. How does it know that it's losing that natural convection?
Because
Or-
because we can tell that the fans are spinning in a direction they're not supposed to, and we can sense that. So we're going to tell the fans, listen, you're spinning in the wrong way. You're not supposed to be. Spin backwards to lock it in.
That was going to be my question, where basically I was thinking that it was almost like an economizer, right? Where like you're setting out what voltage to control it. And typically on like an economizer, VFDs, you have a feedback loop that basically tells you what rotation, how fast you're actually spinning. So if you're not calling for anything and yet the thing is running at whatever because of the fans coming on, it knows to basically revert that and slow it down so it's not moving in the opposite direction, actually moving air across the coil, correct?
Mhm.
Which makes for better control, obviously.
Yeah. So another thing that we do is, we have our inverse operation on the units, where you could this there was a guy that called me about a year ago, telling me that our adiabatic unit wasn't maintaining the set point. The fans were spinning at 100% and water was going. I spent an hour on the phone with this guy trying to figure out what was going on, because everything on the control side seemed to be working. And I'm like, I don't get it. I don't get it. I'm like, you know what? Can you send me some pictures of the unit? I want to see this. So he sends me some pictures of the unit, and apparently the unit was on, I'm sorry, hold on, go back. Apparently the unit was on the Las Vegas Strip. And, there was all this nasty debris on, like, plastic bags and all kinds of things covering the adiabatic pads. So there was no airflow across the pads. So the fans were running at 100%, but it wasn't cooling. And that's why it wasn't cooling. So what I had them do is obviously clean the pads off, but then we turn this feature on, inverse operation. And what this does is we set it up so that if the control value was less than 40%, that the fans at any given period during a 24-hour period, the fans would spin in reverse at 100% speed. And what that would do is it blows out all large debris from the coils, from the pads, things like that, while still maintaining your set point. Because our fans at 100% in reverse are still just as efficient as if they were 40% in the right direction. So one thing I'll say about this is it's not the end all be all, meaning if you get cottonwood, it's not gonna do the best job with cottonwood, but it definitely will help, especially if you're starting up a unit and you see that there's that it backs up to a forest and you're gonna get leaves on that thing. Definitely turn this feature on.
So I have another question. So I know one of your competitors has, and it looks almost like trampoline material, like a black material, or, instead of all the stuff, the cottonwood and stuff sticking right to the panels where it would be
Filter.
worse. There's basically like a little filter between there to take the brunt. So you're not getting the cottonwood and then making the cottonwood wet. And then it just basically becomes like concrete on those panels. So do you have some sort of
Yep.
filter material that you can
Yeah,
install in between?
offer with our units could be ordered with that on there.
Okay.
So yep, that's something we offer as well. So another thing is our night setback feature, where you can limit the fan speed at certain times of the day. This is done a lot, like in residential areas. If you're back up to residential areas, so that you can limit the sound. So between certain cities have certain ordinances for sound levels. So that's a feature you can set up with our unit. And then here, I think I kind of discussed this stuff, but here you can see our natural convection control, how it'll spin the fans backwards right here. We have the bypass valve control. This is just a slide that goes over that and shows it a little bit more. And then we have our LCMM, which it'll use 1, 2, or 3 fans as needed and increment as we need it, and go up to 100% as you need it. And then this is the adiabatic operation. I haven't really got into that, but I will. So with our adiabatic side, and that's one thing I do want to talk about too, is the adiabatic control, but I'll get into that right now. Let's go over here. So this one here, this slide shows how we have individual bus lines from each fan directly to the controller. So there's no configuration required. So if you need to replace the fan, all you have to do is drop it in and rewire it, and it comes alive. I know a lot of technicians appreciate that instead of having to program certain fans. So, but that's a blowout of our actual GMM controller. You can see we have a rotary push dial, so it spins and pushes. The user interface on our new GMM is a lot nicer compared to our previous generation. This is the USB port where you can upload and download configurations and upload the software. We have built-in Modbus TCP and RTU in the controller, just everything. But
Hey, Will,
to
can
the
you hook a laptop to that and like quickly program it? Like, is there like a quick start program, like it's so you're not having to go through the interface if you did have to do it, or is it just the USB?
well, we have quick start guides. What I found, I actually put some quick start guides together, and what I found is everyone always goes back to the USB to upload it. So the USB is easier, but we do have some quick start guides.
No, I mean, like, can you plug a computer into it and like program it?
Oh, no, I'm sorry. Hold on. No, you can't. Not right now. There's talks about potentially doing a web interface in the unit in the controller, but that's for future development. It's not in there right now. Yeah, you would have to either go through the user interface or upload via USB.
Yeah, the quick start guides. If you could like post the link to me or Brett for those, like, because I mean I had trouble finding those, and that would be like killer to have a quick start guide, but just how to set it up for analog an analog input, or a quick start guide to set up at LLM.
Yeah, yeah, yeah. No, definitely. I can get you guys that. That's not a problem.
Awesome.
Have you ever had to have any of the technicians out there go through and potentially connect to the what type of actual fan motors are there? Are they the empaths ones?
Yeah, EBM.
Are the okay? So have you ever had to have a technician connect right to it and like change some of the programming internal because it was programmed for the wrong RPM or whatever have you?
So when on our high side units,
Mm.
our GMM, once it's connected directly to the fan, programs the fan automatically. So a technician should never have to connect to it. On the low side, on the evaporators and stuff, that's a different story. That maybe that has happened. It's rare, but it has happened. But when you're talking about our high side, our dry coolers, condensers, the GMM will program the fan directly. So there's no need for programming the fans. That's why that's exactly why when you load one configuration from one controller to a next unit, that's why you have to tell it the fan ID and the fan RPM. So that's one of the things that asks you for when you're loading it from, let's say we go back to that example from a 12 unit to an 8 fan unit. It's going to ask you for the fan count, the fan row, the fan ID, and the fan RPM. And you put that in the controller, and the controller programs the fans. So now getting into the adiabatic side. This is so right here we have our GHM controller. So on the left, we have our GMM, and on the right, we have our GHM. Now, when I say GMM, that stands for Guntner Motor Management. GHM stands for Guntner Hydro Management. And the way that these work together is the GMM will control the fans and ramp up the fans up and down. The GHM looks at the ambient temperature, the ambient humidity, and the GMM tells it what the fan speed is, and it'll determine how much water to put across the fans. Okay. The water lines. So inside of this block here, we have a water meter, a control valve, a drain, and a drain solenoid. All these tie back to the GHM controller to determine how much water to put across the pans. So we have a few different modes of operation on this thing. We have a water savings mode, energy savings mode, and an efficiency mode. Water savings is used primarily where water's scarce or water's expensive. A lot of the Southwest will definitely use water savings. Around the Midwest, where water's cheap, around the Great Lakes, I should say, where water's cheaper, they'll prioritize the fans and use more water, and then you can do efficiency mode. So basically, the way this works in this example here, what it's doing is it's waiting for fans to ramp up to 100% and the ambient temperature to be 80 degrees Fahrenheit before the water's used. And that's normally water savings. So from our factory, all of our units come in water savings, and those settings are 90% fan speed, 71 ambient temperature for water to kick on. So let me say that again in a different way. So the way it'll work is that the GHM controller is going to be looking at the fan speed, and if you don't touch it from the factory, it's going to wait for the fans to get to 90% fan speed and the ambient temperature to get to 71 degrees Fahrenheit. And then it's going to kick the water on, and it's going to continue to use the water until either the fans drop below 80% or the ambient temperature drops below 71. That's water savings. Energy savings, we're prioritizing the fans, and we are using more water. So it's going to wait till the fans get to 30% in this example, and the ambient to be 60 degrees Fahrenheit. So as soon as it's 60 degrees and the fans are at 30, then you're going to use more water. So what's happening is you're not going to use as much energy. And then the third mode is efficiency mode. This is really nice. Not a lot of people use this because you need to have a little bit of information for this. But if you know the cost of water and the cost of energy, and you can put that inside the GHM, our controller will determine which is better to use and operate in that method.
So it's actually smart enough to figure out which way is the best way to save energy at that point. Now when it's talking about saving energy, it's just talking about the energy consumption on the gas cooler at that point, correct?
Yeah, the energy consumption of the fans.
Okay.
Yeah, exactly. In here, you can actually see this is a picture of the water meter, the actuator, and the drain valve. Now,
Hey guys, today's episode is sponsored by Westermeyer Industries Serviceable Oil Floats. Many oil separators contain an oil float to effectively meter separated oil back to the compressors. Westermeyer Industries has taken this concept and perfected it with their new line of serviceable oil floats. These floats feature an improved design with fewer components, allowing for greater manufacturer consistency and up to 20% increased oil flow versus their legacy models. These floats also feature an integrated magnet to shield the oil path from debris and have been field proven in supermarket applications. Westmeyer Industries offer replacement oil floats not only for their own separators, but also cross-compatible models for our competitor oil separators as well. You can find out more about the Westermeyer Industries serviceable oil floats by visiting westermeyerind.com/floats. Once again, that's westermeyerind.com/float. Let's get on with the episode.
there was so during because of COVID and all of these supply chain shortages, there was we were stuck in a bad situation over the past year and a half. I think Kevin, you brought this up, how we have two actuators inside of there, and they were never programmed properly from the factory. And I saw it, and I apologize for that. But I just want to give you guys the backstory for that. So during the shortage, normally we don't use two Belimo actuators, one for the feed and one for the drain. Normally we have a drain solenoid right here. And now we got them back. So we're installing them. But during the shortage, since we couldn't get the drain solenoid, what we decided to do, it was either hold up the unit and not ship it out or figure something out. Well, we had Belimo valves, so we repurposed them as a drain valve. And because of that, we had a little bit of a growing pain, and there was some times where they weren't set up properly. And like I said earlier, when I see these things, when I hear these things, I do go back to the factory and we work on it to fix it. So there was a problem where they weren't being shipped properly, where the drain was reverse acting instead of direct acting, and it was causing a whole lot of problems where it was draining when it shouldn't. But I think we've worked through that now. Hopefully, you guys don't see that as much. But another misconception about our units is that they're pump and dump and they use a whole lot of water. Well, what we do is because we have it's a control valve feeding the adiabatic side of it. We meter the water that goes across the pads, and so it's not just on off, and it takes into account the ambient temperature and humidity. And on days where it's more humid out, it's going to use less water than on days that it's less humid, because adiabatic cooling is not effective. The adiabatic cooling is not as effective on very humid days. So there's no point in using water. But on dry days, it's very effective. So we take all those things into consideration and we put water across the pads to make them as efficient as possible. Another thing is we do record internally how much water is being used in this unit. So if we ever do come across a problem where, hey, this unit's being dumping a ton of water, well, let's see, let's go in there and let's find out exactly how much water it's used. We can do the calculations and figure that out. A lot of times what I see is it's a visual thing because it's a once through system. It's not a system where we recirculate water. Because whenever you recirculate water, that's a whole other issue. You got water treatment and pumps and other things that you have to do to recirculate water. And it's also opens up the door to nasty things like Legionella and things like that. So we don't recirculate water on these units, but we do meter it and make sure that you're not using an excessive amount of water.
So how do you guys keep the scale from the entering water from gumming up the pads and the actual coils? Because I mean, you're from Chicago, obviously. So I mean, we have like shit hard water up here pretty much. I mean, pretty much everything around the city is it's hard water, especially when you get out in the suburbs. I mean, you look at some of these condensers, like normal condensers that guys run sprinklers on, and after a year or two, they're ruined with scale.
Mhm.
How does this not do that also? Because
Well,
it's entering non-cleaned water.
yeah. Well, I think the water in Chicago is probably going to be some of the best in the nation, but that's a different subject. As far as water and water scale, it's normal city water, so it's gonna it's gonna have that. These pads are not designed. They're not like a coil. They're not designed to be there for life. They are consumable parts. Every one of the adiabatic pads, and it really depends on the water quality. I've seen customers. Some customers have told me what they've done, and is that they've put like water filters before the unit to filter the water that goes to the unit. That's not something that we do or we recommend. I'm just saying that that's something that I've seen that customers have told me they've done. But depending on water quality, I would say 1.5 to 2 years it would have to be replaced. I've seen places that have really good water quality and they haven't had to replace them. What some customers will do is they buy 2 sets of pads. They take one set off and then they'll clean it with this, like, just a small, like a soft brush and a garden hose. Don't use a pressure washer on these, but some mild soap and clean it off and then put it back on. I've had customers that, especially if you go to like Arizona where they have really, really hard water, well, some of those guys have had to replace it every 6 months. It really depends on the water quality. The thing is that this isn't going directly onto the coil. It's going onto the pads. So that's something that's it's not affecting the coil.
So no water treatment is recommended, but it's not going to avoid any warranty or anything if I throw some filters on there, just trying to do better for it, right?
Yeah, yeah. I mean, that's not because you're just trying to improve the water quality. The only thing I would say is make sure that the water pressure to the unit is around 30 psi. That's kind of what we're looking for.
Is that how you're figuring out? Because I was about to ask you, because like, I mean, everyone's going to have a little bit different water pressure coming in. And I'm
Mhm.
assuming you're taking that stagnant, 30 PSI, 35 PSI, whatever you want it set for. And you're using that for part of your calculation and try to figure out how much water consumption that you're using.
Well,
Is that
because
correct?
because we have a water meter and we have a control valve, we know how much water is going past in there. So let's just say you're at a site that has 20 psi, and then so the water meter, the valve opens up 10%, and it's going to know how much water is going through, but it's going to say, you know what? It's not enough. It's going to open up 20, 25, 30, and it's going to open up more to satisfy how much water it needs compared to a site that say has 35 psi, has a little bit more pressure. The water valve just isn't going to have to open up as much.
All right. And then the humidity sensor you spoke of, that's before, it's in between the panel and the
Well,
actual
there's
coil,
the
right?
one, if you're doing floating set point,
Mhm.
that's when you'll need a humidity. It's not a humidity, it's a temperature sensor that goes behind the pads. Now, every adiabatic unit comes with its own temperature and humidity sensor, and that gets wired directly to the GHM controller. So the only time you'll need well, if you have a temperature sensor behind the pad, that's when you can do the floating set point. It's not going to look at the temperature humidity sensor that's on the actual unit. It's usually installed on the opposite side of the control panel, so it'd probably be right around here. Control panels here. You have your Belimo valve and water meter and stuff that would be over here.
Sure.
So, and then another thing that we do is we do have freeze protection built in. So if the water is stagnant for 24 hours, if it's not in operation for 24 hours, or the ambient temperature drops below 42 degrees, we're going to drain the lines in here so that water doesn't crack the distribution lines or no bacterial starts to grow or anything like that.
Well, if
So
you lose the humidity sensor, because we've ran into this, and if we lose the humidity sensor, is it supposed to shut the water down, or will it go full?
Safe. Yeah.
So what happens when it's 90 degrees outside and it needs the water? Is there a way to override it
Yeah.
besides?
So the Belimo valve on the Belimo valve, there's a polarity switch where you can just swap it. And so if you open up the cover, and I think I actually have a Belimo valve right here. I don't know if you can see it or not, but there's a little polarity switch right in there. You could take a flathead and change it. And what that'll do is instead of being closed, it'll open the valve.
Yeah, because we ran into that with a couple of them. We had a couple of humidity sensor failures and or people hitting them with things, and we ended up having to do the exact thing. We ended up having to override in the Blemo, but I didn't know if there was a way in the controls to actually force them on if there was a humidity sensor failure.
No, and the reason we don't do that in the controls, because I'm sure you've seen it. There's a lot of guys that know just enough to be dangerous. And if you get a guy out there that's just messing around with it for starting it up and puts it in manual mode and overrides it and forgets to turn it off, then it freezes. The weather gets to below freezing and cracks the distribution lines. That's a much more expensive fix. So
Yeah. I mean, all the customers now have been making us like every single job has been we've had to put block and bleeds and vacuum breaks in.
mhm,
So they're actually they're draining the water themselves downstairs to
mhm,
keep it off the roof.
yeah. Yeah, no, and a lot of customers, what they'll do is they actually tie into our drain signal. So that's something that a lot of customers have done, and a lot of customers will do. Is when we send a signal for our unit to drain, they use that signal to shut the water off to the unit.
That makes sense. It'd be a lot easier that way, just having one controller do the bleed out.
Mhm. Yeah. So that's kind of what I got for our controls. So I don't know, what questions do you guys have?
I was just happy you called it a pump and dump. I started laughing my ass off. I had to turn off the mic for a minute. So that's one of the first things he said to me. He's like, "Yeah, Kevin's got it a little bit wrong. It's not just a pump and dump, as you guys say." I'm like, "I'm sorry. We'll get
No,
it
no, it's
fixed."
okay. You know what? Like I said, I listened to the last podcast, and that's one of the things I can say that I like about working at Guntner is if we hear something from the field, and it's something we can fix and something that we're doing wrong, we're gonna fix it, and we're gonna do what we can. And setting up the controllers from the factory is something that we've taken upon ourselves for that reason. Because it's a
Yeah, I
project
mean,
I have. Go ahead.
that's the biggest gripe, like with the whole thing is the setup. Because you got the OEM saying one thing, it should be set up, then it's you guys saying another thing, and then it's the OEM doesn't know what it's supposed to be set up to because they don't know what they bought.
Mhm.
I mean, and it's just it's like this chaos in between, and the customers buying stuff from you guys, and the OEM, the rack OEM's not. So it's just
Mhm.
there's just like zero coordination between anybody, and then it's just refrigeration contractors, no problem to make it all work and hash together. But that's been the biggest thing but those quick start guides would be like phenomenal because I mean the manual's huge. You guys have like that manual's in multiple languages and it's quite big.
Yeah.
So for the temperature control, is there any specifics that you want your sensors to be at, right? I mean, some people are finicky where they're doing anything controlling droplet temperature. They want to be either at 3 or 9 o'clock. They want to make sure the sensor is wrapped first, or I'm sorry, secured down on the pipe with some sort of metal strap. And if you're putting it outside, a lot of times what they'll want you to do is use reflective silver tape, so the sun's not. The sensor's not going to get that that load from the sun just because it's a black insulation tape that they use on the outside. This way, it reflects some of the heat. Is there any kind of specs on where you guys want your sensors? Like,
Yeah. So that's a good question. We, whenever the unit is ordered with just one temperature sensor, we ship that temperature sensor inside the control panel. And the purpose of that is because we want that sensor installed in the common outlet header at least 1 foot after the fluids mix. And we also ship it with a well. So what happens is it gets to the site. Nobody, the pipe fitters never open the control panel. They pipe everything up, and then the sensor's not installed. So if you're ever at our site at a site with a Guntner, open up the control panel, take that well, give it to the pipe fitter to install. Ideally, before it's been the system's been filled.
See, this happens every single job that happens. Exactly what you said, because, well, here's the problem. So I do startup. I generally don't come on site until they're ready to do startup. And by that time, they've already pulled vacuums and, I'm busy trimming out the EMS. You guys need to put a big old fat sticker on that header. And I'm serious. That well must be brazed in. I mean,
Yeah.
that was a lot of it.
Yeah. And then another thing too is when the unit is ordered with 2 temperature sensors, then we install them on each coil. So that's another thing too. So
You
I
guys
see more and
look
more
at-
now that a lot of the newer, a lot more that's happening a lot more often now that 2 temperature sensors are being ordered because the cost difference between 1 and 2 isn't different, but it makes everyone's life a lot easier.
So do you guys have the ability to do split control off that controller too, for the fan controller
Yeah.
for
Yeah.
for a split valve?
Split valve or split?
So like,
Condenser.
okay, we can split fans, we can split the condenser, but I mean, do you guys also have the ability to split the condenser in half, like the valves? Like, so you would have a valve on the inlet to the coil to be able to shut the refrigerant off and to one side of the coil, or does that still have to be done by some other control system?
So what we can do, we do have external valve control. We can look into that a little bit more, see if that would be what you're asking. But one thing I think that would be beneficial, especially if we have 2 temperature sensors, you can put a split condenser where instead of having, where you're controlling one side of the fans via 10 to 0, you're actually putting 2 set points in, one for each side of the unit. So you're trying to maintain, I don't know, 90 degrees on one side and 62 on another. And that our unit is capable of doing that. You're having two coils, 2 set points, and our fans will ramp up and down independently of each side to maintain those different set points.
No, it makes sense. I like that. Like, I mean, that way you could have two different racks on one condenser, like
Mhm.
some customers
Yep.
like to do.
well, you said you also have external valve control. I mean, you could basically uh, jump around the signal, right? Because most of those EBM motors, they have 10 volts right there. So you could either kill the 10 volts or give the 10 volts, and split half of the condenser still using your controller wheel, right?
Well, we're not. So when the EBM motors, we don't send a 0 to 10 volt signal to them. We actually communicate via Modbus. So that's another thing. So that's how we get all these advanced features in there, because we're able to tell it what to do, and we're communicating with the fans. I'll get some guy calling me, say, "Hey, listen, the fan's spinning at 100%, but I can't intercept that 0 to 10 volt signal. I don't know what it's doing," because they're trying to read Modbus with a meter.
Right.
Now, the external valve control, You can control a bypass valve and a heat recovery valve is what you can control. So
Another question, William. So we do a lot of years evaporators too, like a ton of them. So a lot of these I see where they're using resistors for the speed control.
mhm,
Why is that instead of like a programmed fan?
it's a good question. It's a way of getting the speed control easily on these fans. And just, you're going to stump me on this one because that's a project that one of my colleagues actually worked on. And I should know this answer because I know that. So these fans use a 0 to 10 volt signal to maintain the speed. But by using the resistors and only using that 10-volt signal, you're actually able to control that speed to make it to a certain maximum RPM. Does that make sense?
Yeah, so they're basically faking out the signal by using the resistor to bleed it down.
Mhm.
Now, you guys, because we've had some issues with like coils where we haven't had enough throw, we need a little bit more RPM. Do you guys have a chart or anything that shows what resistor you could change those RPMs on those coils?
Well, is it the thing when you gotta get into when you get into that, you're gotta look at the FOA and the MOT and things like that. So when you're taking the resistors out, you're gonna be increasing the RPM, which it's gonna be changing the electro characteristics of the evaporator.
Correct.
So
I was talking like adding a different resistor just to give you a little bit more. Like instead of going from like say it's a 6 volts, raising it to like 6.5 or 7,
yeah,
just to give you a little bit more throw in the coil.
I think those are pretty much set for the most part. That's not something we really recommend doing. If you come across something like that, you can always reach out to us and we can dive deeper into it. But they've been designed that way from the get go. So if there's something wrong, then we can take a look at it. But for the most part, it's not something that we really recommend making a change on that.
Sounds good.
But no, if you do have a situation where it's not the RPM you need or not, there's a lot of other things that contribute to it. But I'm not exactly sure. I'd have to take it on a case by case issue. Let me know. I have no problem with that. And like I said before, if I don't know the answer, I will find someone who does.
Are you the one that also deals with all the controls for all your evaporator controls and stuff as well?
I have one of my colleagues that does that. That's developing more of the evaporator control side things right now. For the most part, evaporators are going out either on and off or 0 to 10.
Because if he's the one doing the controls for that, I'd like to have some conversations with that because
Mm.
there's some things that Kevin and I disagree with how most manufacturers turn the fans off and on, whether it's in defrost or whatever, how they're changing the signal, and I just have questions.
Yeah, yeah. That you're getting more into the refrigeration side of it, and that's where I'm a little bit more on the deep end. I know some stuff, but I don't know if I'd be able to answer that the right way.
No, understood.
Yeah.
Understood. You showed me the other day there was like a certain percentage and stuff, which I didn't see on this slide where it would show you like what the humidity was and what the expected flow would be.
Oh, that's in our IOMs.
Uh-huh.
Um, for every unit, depending on the size, has a maximum amount of water that's used.
Okay.
So that's something that's on our website for the IOMs for each unit. So, but yeah, every unit, depending on size, will use X amount of water. I don't know what those numbers are off the top of my head.
So let's just say 80 degrees, the water, it typically is when the water comes on, correct?
So from the factory, we set it up in water savings mode.
Okay.
So what that means is the default settings are 71 Fahrenheit,
Mhm.
90% fan speed, 90% on, 80 off. So 71 or greater, and the fans are at 90 or more, it'll use water. until the fans drop below 80 or the ambient drops below 71.
Okay. What's really the best way to kind of tell if you're getting the proper flow? Like if we're checking to see if the gas cooler or condenser is doing all that it can, right? Typically after 75-degree ambient, you run the fans 100% and basically find out how much higher saturated condensing temperature is versus our ambient, right? And that'll give her our TD. Is there any kind of hard numbers that you can give us or anything where basically it's like, oh, well, if you see that we're not getting this amount of flow from this part of the controller, it's typically a water flow.
Well, one of the nice things about our controller is it'll tell you right on there.
Okay.
So like if you're not getting enough water,
Mhm.
it's going to tell you right on the controller. It's going to say hydraulics not okay or
Really?
something like that. And you'll get an alarm. So typically if you're not getting any alarms, you're okay. So also visually speaking, you'll see water going across the pads. If you're at a startup, starting the unit up, things to check for, make sure valves aren't reversed. You can manually turn the fan on to 100% as long as the ambient temperature is over 71. Then
Mhm.
you'll be able to test it to make sure water comes on. You can go into the controller and lower that 71 down to like 50 something if it's a colder day out, so that you can get the water flowing and make sure that it's working properly. But generally speaking, as long as you don't see any alarms on there, you're okay. Making sure the valves aren't reversed, making sure. One of the things too that's nice to check is the pads, making sure the pads are nice and flat. Because when the water's coming down, the fans are running. If you see the water dripping off the sides, it shouldn't. It should just be running down the pads. And what'll happen a lot of times is if the pads are offset slightly, that can cause the dripping instead of being completely flat. Also, the PVC distribution lines. If you're looking at the unit from the end, the right side should be facing up and towards. So the right side would be at 11 o'clock and the left side would be at 1 o'clock, the holes on the top. So that it's pushing up and towards the unit. Does that make sense?
No, it does.
Yeah, let me see.
I'm just trying to think of any more questions. I mean, I'm learning a bunch. Kev, you got any more questions?
No, he pretty much answered mine with the control setup and the fan setup stuff with the LLM settings. That was my big question. So, and then explaining how the water system works, I appreciate that. Didn't mean to call it the pump and dump 5,000.
Hey, but you got me on the podcast, right?
We'll downgrade it to the pump and dump 1,000.
That's okay.
Oh my God, you're horrible, Kevin.
It's
So the other thing is, I just want to ask this: where can they access any of the Guntner information? Because I was perusing the site, man. I really couldn't find much reference guide on there.
Mhm. Yeah, I can send you some stuff.
Mhm.
Where we have we have a database that we're planning on releasing where everything is going to have access to it, where you're going to be able to go to our site and get more access. We're currently in the process of just gathering everything together, so it's going to be all at one central location. So it's not yet on the website, but we're currently working on just because it's a lot of information that we do have, and we're just gonna centrally locate it. And we're in the process of making sure that everything is easy to find and easy to get to. So that's another project we've been working on. So it's almost ready.
Cool. Well, man, if you don't got anything else, the only request that I have is get your buddy to come on here and talk about the evaporators that have the mixed signal, because we've had debates on some of the stuff where some of the manufacturers will run these things down to the slowest speed as far as evaporators during defrost, and that didn't really ever make sense to me because I did think
Mhm.
that you would want 100% airflow, because then I think you'd have to increase the amount of defrost time if you would spin it real down real slow. And
Yeah, when you get into defrost time, I defer to my colleagues on that stuff because that's where I'll get a call and they're saying, "Hey, so how much defrost time?" I'm like, "Hold on, let me transfer you."
I didn't hear gas cooler or condenser. Next call.
So if it's anything having to do with like programming a fan or a controller or the FLA or MLP or anything having to do with the electrical controls, I'm your guy. When you get into the defrost sequence and stuff like that, that's where I I know enough to be dangerous, but I that's not my forte.
I lived my whole career knowing enough just to be dangerous.
Yeah.
Well, William, I want to appreciate you. Thank you so much for coming on and explaining that and setting Kevin right that it's not the pump and dump 5,000. That we actually understand fully how the water control works, and I appreciate your time.
Yeah, and like I said, to anybody who's listening, if they have trouble with our units, feel free to reach out. We do have a lot of great resources to make sure that that the units are programmed and set up properly. Because what we don't want is, you know what, if someone doesn't know or just thinks it's not operating properly and never let us know, and then it just gives us a bad reputation when it could be something that's an easy fix. I mean, we try really hard to make sure that every unit leaves 100%, but things happen. And like I said earlier, with the valve thing, we try and improvise to get things going. But anything that we hear from the field, we really take it to heart and try and make it right and, and get the best product out there possible.
See, I wish more manufacturers were like, oh, things will be said, and well, that's just the way it is.
No, we've never heard of that before.
That is the biggest one we get all the time. Well, we never heard of that before.
Yeah. Well, no, I mean, and I know things go, nothing, it's never perfect, especially these past few years have been rough with sourcing parts and getting things out and supply chain shortages, all that stuff. So that's where the root of that valve problem was. But in fixing one problem, we created another one, but we're able to fix it. So
For sure.
yeah.
Yeah. So, Will, any kind of information that you can share, I will put up anything that he does share on the Advanced Refrigeration podcast Facebook group. So you have access to all the stuff that he's going to be sharing with us. Otherwise, William, once again, I appreciate your time.
Yeah, no, definitely. Thank you for the invite. I appreciate it.
All right, guys, have a great night.
You two have a good one.